The regular size, you said. What's that? Is it the use of trees with a...
Well, we define the regolith, I don't know how the geologists may not agree with what you define, but we define it as material which apparently covers much of the lunar surface and has this characteristic velocity of 100 meters per second.
And what comes after that?
Underneath this particular site,
Yeah.
is something that has velocities like fraught marl, breccias.
You said something about you were sure that there was no flow material underneath this. I guess I missed the conclusion.
Well, we've done enough experiments on Earth, and I say that we've been able to recognize flows because the velocities are characteristically much higher. And if you want to argue that there may be very thin flows, i.e. thinner than our sampling wavelength, which is like 2 to 3 meters, they could be there, but we certainly, on the average, didn't see any big sequence of high velocity flows. We would have recognized.
When you say high velocity, this 200 or 300 that you're talking about from the essence stage, that's not high.
Yes, every small crater that we looked into, with exception probably of Buster Crater, we never saw anything that looked like anything but, I mean, it just looked like more of the same, looked like regolith. I mean, you know, we never saw anything that looked like outcrop, and we were sure looking for it.
This 200 to 300 meter velocity you're talking about from the limb ascent, that was this breccia material that you say is underlying the regolith, is that right?
That's my first look at it.
First look.
When do you fire the mortars?
Okay. Oh, that's another good question. What's the latest word on mortar firing? Do we have any idea about when you're planning on doing that?
Well, there's a meeting at 1 o'clock this afternoon, and I'm going to request it to fire it on May the 23rd.
Bastille Day, is it?
And it's armed, too.
Okay, our next subject is a solar wind composition. Dr. Meister?
Unfortunately, there is not much to tell about the solar wind composition experiment. The foil was transferred to Switzerland at the end of last week, and we don't have any results yet, of course. The foil was deployed during the first EVA and retrieved at the end of the third EVA with a total exposure time of 45 hours and 5 minutes. That's some 3 hours longer than the record of the previous missions, which was about 52 hours on Apollo 15. The main difference between the foil of Apollo 16 and the ones of the previous missions is that some pieces of platinum foil have been attached to the previous design, which was composed of a pure aluminum foil. These platinum foil pieces can be cleaned by fluoridic acid, which allows to remove all the possible lunar dust contamination. This technique has been tested in the lab on bombarded foils and showed that you can remove essentially all the lunar dust contamination without losing any measurable amount of trapped rare gas ions or atoms of solar wind origin. This technique should allow us to determine the isotopic composition of the rare gas elements of solar wind origin up to the mass of possibly krypton. A first visual inspection of the foil here at MSC showed that the foil is crimpled but essentially free of lunar dust. That's of course only a visual observation. We don't know how the foil looks like under microscope. I would like to thank the crew for the proper deployment and retrieval of the foil. We are very pleased with what the foil looks like. Thank you very much.
Can't miss when it tells you where the sun is.
Yeah, point this at sun. The thing didn't roll up like I thought it was going to, and I'm sorry I had to crinkle it, but it was so big and that I had to squeeze it down to get it into the bag, and
Yeah,
it ripped once too. I guess you saw that. but-
That's only a problem of aesthetics. It doesn't hurt the scientific
Okay, good.
value.
I didn't think it did.
Don?
If the local magnetic field is standing off the solar wind area, what will that look like now?
We don't know yet. That might be that we have a discrimination between the lighter and heavier elements in the solar wind. We have to check that. Maybe that there's a dependence on the height over the lunar surface of the composition between the heavier and lighter elements. But we have to check that first and see.
It will stand off the lighter particles more easily.
Lighter particles would be deflected much more than the heavier ones.
Can you see those? I don't know. This is probably a stupid question, but these cosmic these particles that cause the light flashes. I was seeing them on the lunar surface during the sleep periods.
Yeah,
Do those things register on your experiment?
No, they have higher energies and they go through the foil.
That's it. Yeah. Huh?
That will show my question.
While the flows are making things bulky, could you tell me the difference in the material between the time you deployed it and the time you brought it back? Was there any realness or anything you might have observed?
No. No difference there. Looking at it one time out the window, I thought I saw some white streaks on it, but